Okay, you see the screen, right?
Yes.
Oh, thank you. So, okay, good evening, everyone. Today we're having some part of practice for your exam. I don't know which one, but still, my tutor asked me to help you to make like a tutorial. So let's begin with string variant, the first one. Today we're gonna check both of them. So the first and the second one, they're quite similar. So maybe we'll have enough practice only with the one. So just a sec. We're gonna start from the 20th tasks, because I hope these ones were successfully done and you have answers for them. So what do we have here is like a typical info question. Like we have a data frame. You're gonna have a link to download it. So I have already done this. What do you do is you just make a new Python file, rename it whatever you want. My computer is a bit slow, so patient, please. Like training variant 1. I'm gonna send it to you after we complete all the tasks. And we need a data set. It's already been downloaded, so I'm gonna just paste the path to it. Which libraries do we need is pandas, like std. I think there is nothing new for you. std. And maybe, I don't know, we're gonna need import numpy as np, maybe. So in my directory, I have the following file called c5csv is the file that we're gonna need. And the first thing that we need to do is to open this file. I think there's no troubles with it, just like we can see that it was a CSV file, CSV table. So what we do is we write PD, like we call our library, read CSV, then we paste our name on the file, just try to open it. Okay, there is no troubles with it. It opens correctly, so we can just save it to the variable like df. And just to remember how it looks like, we can read df.head just to see the columns, our data, and the following. Okay, let's now switch to the tasks. Do you have any questions with it? I hope you were told how to open files, right? Okay, I hope everything is fine. So what do we have here is we need to calculate the average for sale in other countries in millions of copies. And we have a clue here that we need to use other sales variable. Okay, what do we need to do is for sale in other countries. We need to understand which column we need to use is something about countries and sales, like global sales, other sales. Okay, we have the following, the necessary column is other sales, and we need just to calculate the average from this column. How can we do this? It is very simple. Like we call our data frame, then we need to take our necessary column is other sales and just use the necessary function is mean, because mean is just means average. And here do we have some number. We can see that sample answer is rounded up to the 2 decimals. So what we do is just use function around and put number of decimals. Here is 0.05, and we can copy it and paste it in the answer. For sales in other countries, okay, no questions here. Okay, I hope everything's fine. Let's go next. Calculate the median for sales in other countries. The same column, but just another different function. So what do? We just copy this cell, paste it just below, and let's change our function mean to median. Just the same. And what do we have here is 0.01. Copy it, paste it here. Nothing difficult, I think. Let's go next. Calculate the maximum value for sales in other countries. Just the same as we did before. Copy, paste, change median to maximum function. Let's run this function, and what we get, 10.57. Great. Copy it, paste it, done. Question number 23, calculate the number of games that were released for the PS2 platform. So what do we have here? What we've been told to do here is that we need to filter our data only for PS2 platform. How can we do this? Is we need to find the column where we can get this data, and I think that the necessary column is publisher. We can check this just calling our df, then column publisher, and for example, unique values, just to see if there are any PlayStation platform here. There are a lot of data, but we can use just Command F, Control F, PS2. Okay, there is no PS2, so that's not our column. We don't need this. Let's go next. Okay, we have the necessary column called platform. I think it was obvious, but I didn't see that. So we can check again, just calling df platform unique values. And yeah, here we have PS2 platform. So this is the right one. Now we need to check to filter this to get only PS2 platform. So how can we do this? We call our data frame again, then in the brackets, we put necessary column df, not publisher, platform. And then we put our condition, like we need df platform to be equal for PS2. So we can see that here we have more than 2,000 rows about PS2 platform and games that were released for this, only for this platform. And next thing is we need to calculate the number of games. So we just need to get the number of these rows of this data frame, and the only function that we can use here is to put dot after the necessary filter and write a function shape. So here we get a list, not a list, a tuple, I mean, about the size of our data frame, where the first number is about number of rows and 16 is about columns. So we just take the first number, copy it, paste it in the answer, and don't forget about putting 2 zeros after the number because it's necessary for the format. Got it? Any questions? Nope. Great. So let's go next. Calculate the total sales in North America and the European Union. Save the values as separate variables that's not included in the original table. Yeah, your answer, right? Standard deviation. Okay, let's go step by step. what do we need to do is implement two filters, two conditions, I mean, North America and European Union. There are multiple, oh, multiple ways how we can do this, but as for me, I think the most easiest way to do this is just make one filter for both of these values. Like we again call our data frame, then we need to use only one column called the country, I think. NA sales, European sales. Oh, we don't have a column only for countries, so we just need to get North America and European. In North America is NA sales and EU sales. So we just call two of these data frames by putting df, our data frame, and then in two brackets, we just taking our necessary columns like NA sales and comma and the second column. Okay, we have a question maybe here. Oh yeah, thank you, Artem. Let's do this, but let's do it step by step. Like we select NA sales and UE sales. Okay, now we have only these values, and if we put sum for this selected columns, we can get the summary for NA sales and summary for UA sales. Or like, okay, we can forget about all of this, just put NA sales dot sum plus DF sales sum. And we can get the grand total summary for both of these columns. Like, what did I just do is I found the summary of sales in NA and then add the same number for European Union. Okay, in separate variable that is not included in the original table. In your answer, write the standard deviation of the resulting variable rounded to hundreds. But I just don't get this. We need to save both of these summaries or just one value like we got here. Table in your answer. I think as you did previously. Okay, so we can say, for example, summary sales. We save it to this variable. And now we need to find write the standard deviation of the resulting variable rounded hundreds. Well, the standard deviation is like std function, but it works only for the column. Like we select our NA sales, for example, and then we put .std, and here we get standard deviation only for this column. But and as well, we can do this for the DA European Union sales as well. So we now get two standard deviations, but what we need to do here is find of the resulting variable around 100. And so save the million copies. Save the values as a separate variable.
I guess we need to compute the sum of these two variables, like sales in North America and European Union, and then compute the standard deviation of these two numbers, if I'm not mistaken.
Daria, I'm really sorry, but can you speak louder, please?
Oh, sorry.
Yep, Thank you.
I guess we need to compute the total sales, like the sum of sales for North America and European Union separately, and then compute the standard deviation between these two numbers.
Oh, okay. So if I understand you correctly, maybe new column. Just okay, Artem, give me a minute. We save, for example, summary NA, this value. We do the same thing for European Union, as you said. And then we find NP STD. Maybe we have this function, I don't know. Yeah, we have this between two of these numbers that we put in a list, like this and this. You mean this, right?
Yes, I meant that.
Okay, we will see that later. But now we can use this number as an answer. Where we put
Actually, in Excel, I got a different result.
different decimals or the digit as well?
Digits as well.
That's kind of interesting. So Artyom suggests us to do the following. We need a new column where we sum up the rows. Yeah, you're right, absolutely. So Artyom gave us a great idea. So what we do now is we create a new column called, for example, total sales. How can we do this? Is we call again our data frame. We put a name of the new column like total. Okay, maybe not total, but NA U sales, where we just sum these two frames. Python is kind of clever guy, so it understands that we need to do this row by row. And if we have a look at our frame after this manipulations, we can see that we made a new column, like we did, like we called before, and this number is made from adding this and this numbers. So, and only after this operation, we can just select this column again, sales, and find the standard deviation like this one. Did you get the same number, Daria?
Yes, I got the same number.
Perfect. So what we need to put in an answer, rounded to 100. So we need to round this number up to hundreds. We use function round and put two decimals. And what do we have here? 1.24. Nice. I think we can go next. Okay, train variant 1, task 25. Any questions about this task, by the way? Nope. Nice. Calculate the Metacritic team's average aggregate rating for the games published by Nintendo. Okay, there are lots of letters here, but what do we need to find at first? That we need games that were published only by Nintendo. So this is the first filter that we need to apply. Like, what do? Is we call our data frame, then we select necessary column called publisher. Here, we put the condition that it should be only Nintendo. Let's check it. Great, we got games that were published only by Nintendo. And now what do we need is to calculate Metacritic's team's average aggregate rating. So we need to find the necessary column called rating, maybe a critic count. User count, user score, critic count, teams average score, user score, developer rating. Okay, this is not year of release. Nope. Team. Do we have a team here? Column team. Oops. Look at the description of columns in the beginning. Okay, thank you. Games developer, aggregate rating of Metacritic users, number of experts. Oh, okay, critic score. This is a necessary column because it's aggregate Metacritic team rating. So we select this column. We can just add it here and got numbers. And then we just need to find the average value. Like we did before, we put function min and round it up to 2 decimals. Like we did before, nothing new. 75.53. Right? Okay, great. The next task is calculate the number of missing values of the Metacritic's aggregate rating, like critic score variable. Sorry. So we just do the same. We take the whole data set here. We select the necessary column critic score, and then find the number of missing values. The necessary function here is null or is an A. I'm sorry. Yeah, I'm back here. So we have two functions that will help us with it. Is null, is nay. They do the same. Both of them do the same what we need from them, and then it just puts a mask where the value is an A or not, and false and true values are just equals for 1 and 0 respectively. And then we just need to sum them, and this number just performs as the amount of missing values. So we just copy it, paste it here, and add 2 zeros because we need 2 decimals, no matter if the digit is integer. And just to show you, if we use is an A, just a sec. It will give us the same number because they're the similar functions. Okay, great. Replace missing values of the critic score attribute with a median for the attribute. In your answer, write the average for transformed attribute. Okay, what do we need here is that we need to fill the missing values. How can we do this? We have a great function called fill_na, where we put the necessary value inside the brackets. And here, replace the missing values with a median for that attribute. So what do? Is just select our column, critic score. Then we use our function fill_na, and we need to use median value for that attribute. So we just copy this column, paste it here, and find the median value. Median. So Python will just select this column and paste this value inside the missing ones. And after this one, we need to write the average of the transform value. Okay, we can save this column like here and find the mean value. Yep, here we have the answer. Just don't forget about rounding this number up to two decimals. Round 1, 2. Great. Now we copy it and paste it here. Wakey, wakey. It's time for school. Nice. Okay, last task, make the scatter plot for NA sales variables on the horizontal axis and UA sales on the vertical axis. Select all correct statements. So how can we implement graphs? Is just importing the necessary library. Import from matplotlib, import pyplot spltf. I hope it will work. Nice, import correctly. And what can we do here is just use our library plt, then scatter. Yeah, right. Then we need to paste x and y values, like we on a horizontal axis, the x axis, we need to put NA sales. So what do we write? X equals df NA sales and the European Union on a vertical axis. So we just put another parameter df EU sales, and it gives us a plot. Not the best one, but still. So we need to put one or multiple answers, but the correct ones. So there may be a positive linear relationship between the NA and UA variables. Well, we can see that if we put a line here, the more NA sales, it gives more European Union sales, but still it's some kind of strange correlation. We can check this, by the way. If we put df, then we select our two columns, this sales and this sales, and use the function for, it gives us 0.76. It's quite strong correlation, but let's now skip this answer, but keep in mind about it. The given plot shows the sample is unequivocally the union of two normal subsamples. What does it mean? In a way that there's no doubt. Okay, I got this. Of two normal subsamples. Actually, it's kind of strange explanation. Do I understand what it means? Like the meaning of this phrase? What can I say about the correct statement is this one, because we can, if we have a look on this plot, we can see like this dot, and other that are not in the many groups of another variables. So it looks like there may be outliers because they're too far from the group. So this answer is definitely right. There is a negative linear relationship between, okay, this is definitely the wrong answer, because we can see that, as I have said before, the more NA sales we have here. So the more European sales on the vertical axis. So maybe I think if this answer is wrong, we can put a tick here, just because it really looks like there is a positive correlation, and we have a value of 0.76 about correlation between these two samples. But do you have any ideas about this answer? Like, what should we understand here? Given plot shows the sample. Okay, we will do like the typical high school economics student. We go and paste it here in the translator. I hope the tutor will forgive me. This is a union of two normal samples. Okay, great, thanks for the image. But let me just между the wrong statement. Okay, I got your idea that if we combine this, if we combine these two columns and just make a plot. Okay, this is the wrong one. One kind equals line. I hope it will work. No, it's not the necessary one. But if you have a look in the chat, it looks like if we combine these two samples, we have two not outliers, I forgot, two high peaks, and it means that there are no single distribution like normal one. So it means that this answer is wrong, because it would look like DF, for example, NA sales. What? Yeah, this is the wrong one. I don't know. This. Okay, never mind. What I was telling you is that if this answer was right, we would get normal distribution graph. We would get something like this. But instead of this, we got a graph with two high peaks and something low value in the middle. So this is wrong. Thank you, Anastasia. Okay, great. We can go next. Any questions here? Nope. Okay. So the last page, but not the least. What do we have here? Okay, another graph. Decide which graph is shown on the picture below. X-axis and Y. So to complete this task, we just need to go one by one answer and try to find the similar one. What we do here is just copy both of these columns. Let's get a plot of critic score. Just we copy this, paste it below, and just change our necessary columns like critic score and user count. Let's check this. Does it look like this one? No. So this is the wrong answer. We copy NA sales, paste it here, and user count is already been here. Run this function. No, it doesn't look like this one. We can just skip this answer because it's not a histogram. I think that it's obvious because histogram just looks much more different. So if we copy global sales, paste it here, and take NA sales for vertical axis, we will get just the same picture as here. So this is the right answer. I think that it was easy. Okay, task number 30. Calculate the correlation matrix of the numeric variables. Calculate the variables that has the highest model correlation with the NA sales variable, not including NA sales, of course. In your answer, write the model of the result correlation value. So what do we need to do here is just get a correlation matrix. How can we do this? We select our data frame, then use our function core, run this function, and it will need some time to think. And what we have here, the error. Couldn't convert string to float. That's kind of strange because core math correlation Pearson numeric only. What we can see that inside these brackets there is a parameter called numeric only that is false by default. So we can just change it up to the true. So we will have only numeric values, like we write numeric only equals true. And we have our correlation matrix only for numeric variables. So what do we need to calculate is the highest model correlation with the NA sales. So here we can just select our necessary column, NA sales. Now we have here the list of correlations only for this column. If we put function ABS like absolute values for this column, we will get only the positive values. And if we sort values for this data, we will get the ascending form for our columns that have some correlation with NA sales. And here, except of NA sales, the highest by module with NA sales is NA UE sales. And I think it's kind of obvious because it has it was made from NA sales. But by the way, I think that we don't need to use this column because, or maybe we should. Because if you have heard something about multicollinearity, it's sort of example here because NA UA sales was made from NA sales, and of it's obviously will have the strongest correlation with NA sales, not including NA sales itself. In your answer, write the model of the resulting correlation value. Okay, let's try to paste this value, but if it's going to be a mistake here, I will text to the tutor to tell that we don't need to use the columns that we have already made because it will confuse you. So we need to paste here answer with 2 decimals. So we just can use function round up to 2 decimals, and we will have 0.97. I hope this is the answer. But if it's going to be the wrong one, so we should need to use the global sales. So the next one, estimate linear regression whose equation is as follows: are the sales, blah, 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 blah. Write the value of the coefficient, estimate if there is a free term. Guys, I hope you had the necessary library to put this linear regression. Can you give write it in the chat, please, if you have it. Please. Nope. Okay, let's just Google it. Python library for linear regression. Okay, I remember something about sklearn. So we just go on this page. Yes, so we import our function like from sklearn linear regression, import linear regression as LR. And it works wakey. Nice, it's worked correctly. So what do we have here? We just use our library LR dot feed, and we put X and Y values here, like we have a function like from the right side of the equation is NA column NA sales and GP sales. So we just paste it here. X is gonna be DF with multiple columns NA sales and Japanese sales, GP sales, and as Y value is gonna be other sales. So we select it from our data frame, other sales. Fit estimator. So oh, I forgot how to do this. It was so far away. X, like just have an example. Okay, linear regression, fit, blah, blah, blah. So we just copy it, paste it here. Where? Okay, let's do the following. We just define our class that will help us to fit our values. We can delete this. Right, like variable LR is going to be our linear regression class, linear regression brackets, and then we put LR fit. Nice. And then we have, as I remember, summary, something like that. Score predict. Summary. No, there is no summary. But the task is write the value of the coefficient estimate if there is a free term. Summary. Okay, let's check this. Summary 2. Okay, there is no summary 2, maybe without it. Nope. Artyom. Nope. If we take coefficient score Koyev. Okay, let's take this attribute. Oops. Okay, here we got the coefficients for NA sales and Japanese sales. It means that if we write this equation, we W1 and W2 are going to be this, like this values, but we need to paste of the coefficient if there is a free term. What does free term mean? Like we need to find the V0, W0 value, right? Or not? It the W0 is intercept. Wait, what do we have here? Yeah, I hope the missing value is intercept, like this one, because if we take for F, it will give us the W values 1 and the second. But I hope the answer is here is the intercept that is equal to W0. So we just round this value up to decimals and get 0.01. Free term. Okay, maybe we will check it later. And the last task, we need to do the same thing, but find the value of mean absolute error on the training samples. To find the mean absolute error, we need to import this function. So we go to this website, paste mean absolute error. Find the metrics. Where is it? Cross validation is not the necessary one. Okay, here we have some sample of code. We just can copy it. Go next, import it. So now we have myem function as myem. And what do we need to do is on the training sample. So we define our linear regression again. Then we fit our values and then we predict. We will predict the already used columns. So we got a list of possible answers for our other sale column, right? And we just put my function here to calculate mean average error and got the, okay, y predicted. If we have a close look on the necessary parameters here, is y true and y predicted. Not the y predicted and y true. So we can save our predicted values here. Like y predicted. And nice. And if we use our Maya function, we put y true is our df other sales values as true because we already know them. And the predicted values like y predicted is y predicted. And get the answer. And still we need to round it up to the decimals. 0.04. Copy it here, paste it here. And I'm here to listen to your questions because I'll try to finish this attempt just to get the answers, whether we were right or not. Did you understand the ways that I used to complete this task? Nice, you agree with me. So let's finish our attempt just to see. Right, zoom. Okay, we got only one mistake here because, as I already said, we don't need to use this column. Like we were told to make this value, but we don't need to use them next. 0.94 is the answer for global sales. So during your exam, forget about the columns that you have already done. Okay? And you will get the right answer. Okay, perfect. Guys, I have a simple question for you. Can you comment? Of course, let's go back here. Select the correct statement about the evaluation method applied in a linear regression model with a constant attribute trained using MSE minimization. Mean squared error, mean absolute error. So let's have a look. Do not see the answers. Let's go one by one. Mean square error and mean absolute error cannot coincide for such model. What does it mean? Well, this is the wrong answer because okay, maybe I was wrong about it. Metrics implied to a linear regression model for such model. Okay, let's skip this because this is this task implies only one correct question. So if all the rest answers will be wrong, so we can put this as the right one because right now I don't have any clue about this task. So R square is not the what? Okay, enough measure for evaluation for this model. Well, this is a wrong and this is a wrong statement because R square sometimes, not sometimes, usually used as a measure for evaluation the model. So we just use linear regression to get R square to see whether the model is correct or not. So I think, as for me personally, this is the wrong answer. For such model, mean square error will always be less than my. No, it's wrong because if there are some outliers, the situation can be different, very different. Like mean square error will be much higher than mean absolute error. It all everything depends here on the data that you're working with. So this is definitely the wrong answer. So the last one, maximizing R square in this model is equivalent of minimizing MSE. Well, actually, this is a true answer because if we have a look on a linear regression graph plot, I mean, yeah, we have here. Let's take this plot. For example, imagine your data. We have two values in its distribution. So the linear regression tries to find the perfect line that will get the highest R square because R square just explains the variability of not the variability, the variance of our data. And if we have a closer look, mean square error finds the difference between, for example, this point and this line. So if we try to maximize our R square, it means that we need to find the line that will go as closer as possible for these values, for these dots. So please tell me in chat if it was if you got my idea, because if it's not, I will try to explain in another way. Yes, no, maybe. So as for me, here the right answer is the last one. We can check this. Yes, this is the right one, because as I have said before, maximizing r squared here is just means that we're trying to find the line that will try to go as closer to this, oh sheesh, as closer as possible to these dots, to these points. And this means just by explanation, the mean square error, because mean square error just trying to calculate the difference between the line and these values. Maybe I can, yeah, I can draw here. Like, look, mean square error, take, for example, this value, goes here and find this difference. The absolute difference between these 2 points. And the linear regression is trying to find the line that will go as much closer to this dot, to this point, as possible. Okay. Yes, no, maybe. Okay, Artyom, I hope it helped you. So guys, answer for seems strange. Okay, let's check this. We go to the task 2. And here we have a graph. The figure below shows a histogram of some variables. Choose the wrong statement. X-axis, Y-axis, number of observation. Okay, this is a typical histogram. We need to find the only one right answer. The median of the variable is 0. What do we know about the median value? Is that it shows the most frequent values in our data. So histogram will perform it like the most highest column, but here we have the highest column is somewhere around 1, and the value that equals 0 is not the top one. Oh, wait, I was mistaken. This is not the median. The sentence about models is also seems to be right. Most. We will find it. Just, I understood that I was mistaken about the median values because I just made the mistake, and I was thinking about the mode value. What I can say about this answer is that it's kind of difficult to see the median value on this data because we don't. Okay, we understand that the values between negative 0.5 and positive 0.5 are most distributed. So there are more values from this distribution, not distribution, just like least between these two values. Понимаю. I'm very sorry. But let's check the other answers. It's simply this task is usually made like if all of them are wrong, this is the right one. Got it? So the variable is most likely a mixture of distribution. Well, this sentence is kind of right because we have distribution of values between these two ones and between the positive above 0.5. The next one, the variable can be continuous. Why not? It might be right because we can see that there are some values, for example, 0.6, 0.7 maybe. We don't know the data, but still. A series of values of a variable contains at least one mode. Yes, it's true because mode performs as the most frequent number, and here is something a little bit more than one because it has the highest column here, so it displays more often, like if you understand me. So if I were you, I would choose this answer because the others are quite strange and I'm not sure in them. But a series of values of variable contains at least one mode, it's definitely true because we just found that the mode is somewhere here. Thanks. The median value variable is 0. Why that? I'm not, I disagree with this. It's not that obvious as I could think, because how can you just see the median value when you don't know the data? This answer, a series of values of variable contains at least one mode, is more trustful as for me. I'll text about it to the tutor, so don't worry. I hope you won't see this task on your exam.
We need to pick a wrong statement.
We need to pick. Sheesh. Okay, this was my mistake. So if you remember my explanation about all of these answers, I told that all of them except of the first one might be true because it seems like there is nothing wrong with it. But the first one was kind of strange because we cannot be 100% sure about it. So if we know that the other answers are right, so why don't we pick this as a wrong statement? Agree? Yes. I hope you understood. Any other questions about the tasks? What I can say is that training variant 2 is just the same as the first one. So I highly recommend you to do this by yourself. And if you have any troubles with these tasks, you can just, with no worries, tell me and I'll help you with it because I'll send you this Jupyter notebook page so you can just change the values of the necessary columns and get the right answers. And don't forget about about this task where you do not need to use your already made column. Got it? What is speed up sticker, Anastasia? Good. So I think we have nothing left. If there are no questions. Okay, have a nice evening. Bye.
Thank you. You too. Bye.
Bye-bye. So we put here.